Now, in the previous video, we saw this. We read this question and decided that it was a hypothesis test. The question does not ask us to estimate the mean. The question asks us to prove something. The first example where we're trying to prove that the average weight of baby girls born to moms with gestational diabetes is less than 3.4 kgs. In the second, we are trying to prove that it is greater than 3.4 kgs. And in the third, we are trying to prove that it's not equal to 3.4 kgs. So we know how to set up the null and alternative hypotheses. So in each of these cases, notice that the null hypothesis is exactly the same and it has an equal to sign. So this is how a hypothesis test works. We make the assumption that mu is equal to 3.4 kilograms. It's only for the sake of argument that we say, let us assume that 3.4 kilograms is the mean of the mean weight of baby girls. So what we are looking at here is a normal distribution, and we're looking not at just any normal distribution, we're looking at the sampling distribution. Now, if you remember, sampling distribution is the distribution of sample means. If we take many samples from the population and find the X bar, which is the sample mean of each sample, then we know that the X bars are going to vary depending on the sample, and that's how X bar becomes a variable. Now, the distribution of X bar happens to be a normal distribution. And if it's a normal distribution, what sits at the center of this distribution, in this case, the center of not just the regular distribution of X, the average weight, but also X bar, the sample mean, the distribution of the sample means, which is the sampling distribution, also has center mu. And all this, anything that I'm saying right now is from chapter 13. So you should go back and watch that video if you don't remember it, because this is key to understanding anything in this chapter. You got to understand how the sampling distribution works. So now the sampling distribution has mu in the center, and its standard deviation is sigma over radical n, where n is the sample size. Now, we're saying that for the sake of argument, we're going to assume that 3.4 kilograms sits in the center of the distribution, which means let's make an assumption that the mean average weight of baby girls, all baby girls, so that is the population mean, is equal to 3.4 kilograms. Now, obviously, we're not saying that the mean is 3.4 kilograms. We're just saying let's assume it is. And that's why we don't call it mu, we call it mu naught. So the 3.4 kilograms is the mu naught. Just remember that. Now, if you see the symbol less than if you see the symbol less than in the alternative hypothesis, then we know that it's a left-tailed test. So we collect a sample of women with gestational diabetes. Let's say the sample has, 400, 500 people maybe. Now, we find the X bar of the sample that we collected. So there are 400 or 500 moms with gestational diabetes, and we're going to weigh or find out the weight of baby girls born to these moms. And once we know the weights of each of those baby girls in the group, we're going to find X bar, which is the sample mean. Now, once we get the sample mean, what we do is we convert it to its z value. We've done this in chapter 11. Now, in this case, z equals X bar minus mu naught over sigma divided by radical n. Remember that this is our standard deviation of the sampling distribution. Now, once we figure that out, if you're trying to prove that it's less than 3.4 kilograms, and if we have thought through this carefully, then our z value should fall to the left of, so let's draw another graph. So the z value, when we convert it, we standardize it, the center becomes 0, -1, -2, -3, etc. on the left, 1, 2, 3 on the right. So let's just say our z value, when we convert the x bar to z, this is what we're going to do using this formula. We get a z value, we get a z value to the left of the center. Now, how do we find the p-value? This is how we find the p-value. We find the area to the left of it. And where do we find the area to the left of a z value? It comes from table B. So let's say z is equal to -3.25. Then you take the number -3.25 to table B and find the area to the left of it. Now let's look at the second example. Mu is equal to 3.4 kilograms. So in the sampling distribution, we make the assumption that the center of the distribution is assumed. Remember, we're making that assumption. That's why that's equal to mu naught. So in a hypothesis test, let's say for the sake of argument, 3.4 kilograms is the mu, and therefore we don't call it mu, we call it mu naught. Now, the alternative hypothesis has a greater than symbol in it. And that's the reason why this is a right-tailed test. So our z value is going to fall. So let's look at the z distribution once we standardize it. And using the same formula, we convert the x bar to its z value. And the center becomes 0. Our z most likely is on the right side of 0 if our sample is anywhere close to proving that mu is greater than 3.4 kilograms. And now we draw a line here. The area that we're interested in, which is called the p-value, is the area to the right of it. And that's the p-value. How do you find the area to the right of it? The table gives you the area to the left. So that's what the table gives you, the area to the left of the z value. This you get from table B. And once you find that area, you go 1 minus the number, and that will give you the area to the right. And that's called the p-value. So the shaded area here is the p-value. Now, same thing here. So we have to assume that 3.4 sits in the middle. We standardize both z and the 3.4 kilograms, which sits in the center, so that becomes 0. And what we're looking at now is the standard normal distribution. Whether the z value falls to the left or right, if it falls to the left, we need to find the area to the left and double it up, because it's a two-sided test. In example 3, we have a two-sided test. So when we double up the area, that is going to be our p-value. Now, what if our z value falls to the right of it, right of 0? Then we find the area to the right. Remember, finding the area to the right involves subtracting the area to the left from 1. And once you get the area, you double it up, and that's what is called the p-value. And the reason why we double it up is because it is a two-sided test.